Well, since I've been using my Automatous mower now for over a year, I figured it's time for a second update. I've actually made some nice upgrades here, and I've been in contact with a couple other people who are also building similar devices. So I figure if anything that I've overcome or discovered helps them out, great, more power to them. But it's been a really nice device, so let's just get into it. The first upgrade I did here is my antennas. My GPS antennas. I got kind of stupid last year and broke these off. I had an all different type of mount, and I would whack that, and so I went ahead and made a little magnetic mount, which is really quite good. This is here. Let's go here. This is what I had last year. I had this little 3D printed holder, and it was very weak, which is was intended to be. And I hit up my hand a couple times and broke it off, and I don't know. It just I could do better. But something I also was reading up on is that the DOP, or delusion of precision, could be improved with a ground plane. And I was doing okay. I was getting down to point 0.5 most of the time. But I do have another project coming up with a real low one to the ground. So I figured I needed to kind of, try to eliminate any ground reflections or something. So I came up with this device here with 3D printed again. This is actually just a piece of sheet metal, which I cut round, sanded down, and then punched a hole in the middle. And it's got a little 3D printed receptacle that the antenna bolts through and bolts right down to the mating here on the bottom. So it's nice and secure, especially with the magnets here. And that way if I hit it, I can just put it back again. But what's really nice is that the DOP has fallen. It's not continuous, but last year I hardly ever saw a point 0.4 DOP, and now it bounces around that quite a lot. I still get about point 0.5 and point 0.6 depending on the conditions and trees and whatnot, but I do think this has improved. So that's the first update. The second one has to do um, with this battery right here. When I first started this, I had a slow mower. It was only a 12 volt system. I was using a 12 volt AGM, weighs in at 49 pounds, and it was a very slow, like I said, which is okay to start with because if I had a bad mower, I wanted a slow bad mower, and it's been bad enough with some of the things I've done to it. So, but I thought it's time to increase it because these wheelchair motors are 24 volt motors, and it was just really slow. So I needed to actually increase it. So I went ahead and got a lithium deep cycle battery, which this is, but instead of actually getting two batteries for 24 volts, this is the 24 volt lithium battery. So that way I get all the power I need plus not a problem charging it. I did get the lithium charger, of course, and kind of made it to it. But this has really increased my speed, almost doubled the speed, because I was running around zero point 0.4 meters per second, and now I'm hitting 1 meter per second, which is a pretty, it's a nice brisk walk if someone's pushing a lawnmower and mowing along. It does not bog down my mower a lot. So I thought, well, it's a good upgrade. So okay, and what's interesting? Oh, let's go back here. What's interesting about the battery is Bluetooth, and so this is a three screenshots from my phone that you can get all the conditions and whatever's happening inside your battery that you want. So I thought it was kind of a nice little thing. But I don't want to forget this. The best part of this is that if I was going to go up to a 12 volt system, to two 12 volt batteries, that was going to be close to 100 pounds. This 24 volt battery weighs in at 35 pounds. So not only do I have more power, I have much less weight. So all that extra weight, I would have to be using power to drive that around the yard. So this is, I think, a very good upgrade. I have had no problem with it so far, and I hope it lasts a long time. I've also increased my battery here. These are on this mode. This is just a 6 amp. I think the other one's a 5 amp. But I also got some 12 amp hour motors or batteries. I got a new riding lawnmower, Ryobi, and it came with two massive 80 volt like briefcase batteries. But it also came with two this format 12 amp hours that just plug right into these. So if I wanted to, I could plug in two of these 12 amp batteries here, and that would give me probably about 4 hours of run time, which is, well, that's fantastic. With a 6 and a 5 here, I'm getting an hour and a half probably. So, but again, what I do in my yard, I'm not mowing the whole massive thing. I'm mowing basically two sections of it, one half and one half, and so I rarely go over a 2 hour run time. So normally when I'm actually running this, I got one 12 amp hour battery in here, and then a 5 or a 6 on the other side. I can mate and match these things because I've been using these. Here's one right here. These are these ideal diode circuits, they're called, and you can mix and match your batteries. It doesn't care. It's just kind of a voltage controlled switch. It will not let one discharge in the other, and they have been working out just um, spectacular. So, okay, I know watching mowing is a lot like watching paint dry, but I still got some um, tuning. I think tuning is becoming a lot like programming that is never finished, just given up on. And you can see some little jerks and moves in the wheels here. I won't run this for the entire time, but I like the way that the four wheel because it'll just spin on its spot. However, that's also a problem. If I'm on any little incline, it will drift, and that drifting will then take it off the path a little bit, and it will find its way back on. But that can be a problem. I usually don't have the dogs out when, but this one sort of got out, but it's careful. I lucked out when I designed this gantry system. There's enough height on the mower that I can just take off two bolts, raise the whole thing up, unbolt the blade, sharpen it, put it back on again. That was easy peasy. So I liked how that worked. Yeah, this is just one. This side yard and that backyard would be one mow, but yeah, it just sort of moves on. I have noticed though, let's go here toward the end here, that I need to almost hide where it finishes because it's pretty rough in the yard. If you're mowing on a wet grass or something, it's going to churn the sod up. But I had another snapper that would do the same thing on the hydrostatic drive, and you can see it kind of spinning around and drift a little bit there. So I really probably should do a better job of finding a hidden spot where it's ending instead of actually right here in my yard. Now it's going to drift pretty good right here as it slides down. There's an incline. You see it kind of slide? Yeah, so that's something I've noticed. It's worse on the steeper the incline, the worse it is. But what's nice about this, because I got it all toggled now on my transmitter, and when it does come to an end here, I'm just going to stop that. When it does come to an end, I can just turn the mower blade back on, switch it to manual, and if I miss a couple places, I can just drive it on the way back to the shed and park it there. So let's see here. One of the things I have made a real nice improvement here, I think, is this cross track error I have. I call it a cross track tether. Now this is the relay. It's going to start here, but because this is my test zone, nothing's going to happen in the cross track until it gets to the fourth wave point. So I'll have to jump ahead here for a second. Okay, now I'm getting my cross track error, and then the cross track, of course, is the center of your track going to the next wave point. And it stays pretty good. I got this thing set on for this is a demonstration. I got the cross track error set up at zero point 0.3 meters of roughly 1 foot. And so what just happened here is that I went over that zero point 0.3 meters. And down here you can see the cross track error on the bottom. And that's what the cross track tether does. If you ever get whatever distance you set from the middle of your line, your cross track error, it will just shut off. Now I'm running the RTK on here as well, and I really like that. And that way, if I ever lose RTK, everything just shuts down again until it reacquires that signal. But what's different on this one? This is almost a breakdown. What I did there, I had to toggle it back to manual and then toggle it back to auto. It's going to happen again right now because they're going to make another corner change here, and there it is, 0.31. It went ahead and actually instigated the shutdown failsafe. I have to toggle my transmitter, manual back to auto again, and it starts on its path again. And that's because I had a mechanical breakdown, and even though I had RTK going, the mower was still mowing, and it was driving off in the distance because I had the four-wheel drive and two wheels were still churning, and the other side was free spinning, and that was enough to keep it going someplace. So now I usually run a cross track error of 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 two point what is it 1.75 meters. Okay, if I ever increase if I ever go over 1.75 meters, the thing will just shut down because I found out if all the drifting and everything, I've never gone that far unless there's a breakdown. So that's what the cross track error does. It just monitors how it's going, where it's going. If it gets too far one way or the other, um, it will just basically shut down. And that's been a nice improvement. And it's given me a lot more confidence in the system. I also have come to believe that all my 3D printed things are just consumables because I've already broken them about 3 or 4 times. The first one of these supports I broke just in the shop last winter. I hit my foot on this little side thing walking by it and popped it off. One of them, that's another one I broke. That's why I got the cross track error because once the wheel shim gave way, it drove right into a concrete bench, and I just got it stopped as it met, but it was enough to break one of these. But they've been working. I got two switches on here. Of course, one switch actually goes directly to the mower, and it's just like releasing the lever on the handle to shut down the mower. And the other switch talks to my orange cube to basically it's a button feature to shut everything down if it ever gets hit. Now that takes a little bit longer of a delay, it seems like, but I've not had a problem with it, and I'm hoping I won't be um, testing the envelope on this. So anyway, 1 year in. First off, I mow less than 1 acre. Okay, it's .6 something like that, according to the area generated. And this is not for someone who has a lot of stuff to mow, but it's for my purpose. It's great. I think I got it mowing about 80 some percent of the whole yard, and then I just do the trim work with the other Ryobi electric rider I got. Um, I'm also calling this solar powered because it really is. We have solar panels on the roof in the shop here, and we overproduce in the summertime all the time. But we don't get paid for it. We get paid just a pittance back for net metering. And I figured, well, let's just use it up. So I'm always charging all these batteries during my sunny days. So instead of actually giving the power back to the company and then they sell it full price, I just use it. And that's great. And again, I'm not reinventing the mower here. I've seen a lot of designs out there that people not only make the gantry system and everything else and the mower. Um, this uses a stock Ryobi 20-inch electric. I've actually already got another one in reserve that came with a 6 amp hour battery. I figured that's better than I had before. Um, but it's been running, I've actually used this more in the last year than I've actually used it the entire time I've had it for 5 years. So it's getting a lot more run time. And I do really like that feature that it's just all solar and all battery powered. I have no regrets moving all to electric. Also, one of the things I've noticed here, just as a side note here, I was having trouble with my Mavlink connecting. On this laptop here, I had a trouble with the USB port, and so I have a USB hub plugged in. I got a couple of things plugged into it. And there were times when it would just not connect. It was just like, and it was my mower is only about 30 feet over here in the shop, and it would still not connect. And I couldn't quite figure it out, banging my head, and I realized, well, it may be a current because I was overusing that USB port. So I got the right cable, plugged it into the USB-C port, which actually has an increased current capability based on the older USB ports. I have never had a problem since then. So if you're having trouble with connection, sometimes it will and will not, go to USB-C, higher current. So that's been a good thing. So anyway, this has been it's going to be a short little update, but I'm very happy how things are going, and um, I really think going with this electric mower, this is my 2 cents here, is a good way to start for a simple small mower. I'm not having to figure out the interface of the joysticks. I'm not doing servos for the acceleration and all this other stuff for a gas mower. But of course, I don't have a gas mower. It's a lot smaller job, but it's really a simple one. Now, I had to, of course, create and build my whole drivetrain system, but that's something I've done quite a lot on other features. So, for me, this was a simple way to get started on this. And I do have that larger riding Ryobi over here I've been kind of looking at, but I don't know. We'll see how it goes. And I know there's a lot of people doing some great work out there on adapting their own Ryobis, so I might be following what they're doing in the future. But for now, I am very happy with my automaton. So, well, have a good day.